note card from last week, right? So we can keep using this note card. And then I will add at the end of this class the whole step number 5 on the back. Yeah, because I have enough time. So we will add our piece to the note card today. That way people who aren't here, your note card will be complete with the whole on it. So you might want to grab out your note card as a resource. So it says if the numerator and denominator have a 0 in common, there will be a hole in the function's graph. All that a hole is going to look like, you know, if I've got elbows that kind of look like this, you don't have to write this, but let's pretend this is my rational function. A hole literally just looks like that. So it's a place on the function where you have this little open circle that it's undefined at that point. But the rest of the graph with the asymptotes is all going to look the same. It says, first, you factor the numerator and denominator. You find the hole, and this is what we're going to add to our note card. You evaluate the new function that you create by canceling the common factors at the undefined value. So I'll show you what that means in problem 1. Here's where factoring comes in. You always want to do the factoring first to see if anything cancels. I've got a trinomial over a binomial. What strategy should I use to factor this numerator? I got a trinomial. What strategy do I use? The diamond. So I'm looking for the factors of -2 that add up to -1. So what factors do I use? -2 times +1. So I'm going to write that as x minus 2, x plus 1. So that's my numerator. So you need your factoring skills to be sharp. How do I factor the denominator? What strategy should I use? Yep, what is the greatest common factor? X. So I write x, and then I divide by x on both terms. What do I get when I divide by x? Yep, see I'm dividing this by x, and I'm dividing this by x. So I get x minus 2. What do you see that's the same? X minus 2. So I cancel the x minus 2's. And I write down that my new function is x plus 1 over x. All of my questions are going to come from this new function. So now we're going to practice all those steps from last week that hopefully you didn't forget over the 4-day weekend, but that's what we're going to review all this week leading up till next Wednesday's test. How do I do the y-intercept? So I'm going to do y-intercept, x-intercept, vertical, and horizontal asymptote. What's rule number 1? Y-intercept, I plug in 0 for x. What do you get when you plug in 0 for x? Yep, can I do 1 over 0? It's undefined, so there is no y-intercept. Are you with me on that? I plugged in 0, but I got 0 in the denominator, so there is no y-intercept. What about for my x-intercept? It says set your numerator equal to 0 and solve for x. If x plus 1 equals 0, what does x have to be? -1, right? -1 plus 1 will give me 0. All right, I finally got something that I can plot on my graph. So my x-intercept is over there at -1, 0. All right, vertical asymptote. Step 3, set your denominator equal to 0. This is what you were doing on the refrigerator problem, right? This is actually the same asymptote, right? I've got an x. What's going to make that 0? 0. So same as the refrigerator problem, x would have to equal 0. So that's a vertical line right sitting on the y-axis, which is why there was no y-intercept. That kind of makes sense. Hopefully this will feel familiar if you do some practice this week. So if you're not here tomorrow, we got to figure out, yeah, maybe if you came at the beginning of 4th block, that, or I'll figure out, maybe I'll just sit in here for C lunch and we can do it during C lunch. Does that work if you're here? Okay, so step 4, I compare the numerator with the denominator. So what's the degree? Degree is 1 here. And the degree is also 1, right? This is x to the first power, and this is also x to the first power. All right, so when the numerator and denominator are equal, we peel off the coefficients of x. So this is 1x, and this is also 1x. So it's important to know these are coefficients. These are the power or the degree, right? So these are both 1 equal. I'm peeling off these coefficients of 1 because they're all 1. But you have to know, okay, this is the degree, these are the coefficients. So my horizontal asymptote would be at y equals 1 because 1 divided by 1 is 1. So I'm not doing anything different yet, right? I went through that whole process so far, found all my asymptotes, found all my intercepts. Here's my last step before I try graphing this rational function. I have to find the whole. To find the whole, you're going to go all the way back to this original function. What canceled up here? The x minus 2's cancel. Where would this have had another asymptote? So where would x minus 2 have been 0? When x was what? Positive 2. So positive 2 should have been listed in vertical asymptote here, but because we canceled it, it's just going to become a hole in our graph. So our hole is when x equals 2, because 2 is undefined in the original problem. And when you have an x value, what should you do with it? Plug it in to find the y value. So we're going to plug 2 into our circled function and figure out what we get. What do I get when I plug in 2? I get 2 plus 1 is 3 in the numerator, divided by 2, so 3 halves. So that's 1.5. So the reason I do the whole is because the whole is going to tell me sometimes where my other elbow is. So where is 2 comma 1.5? It's right here, right in that upper quadrant. So this elbow goes through this hole, and the other elbow goes through my x-intercept. And now I've graphed my 2 elbows. So sometimes the whole will help you find your other elbow. If not, you still have to plug in another value to find it. So I took the 2, which was where this x minus 2 got canceled, right? 2 minus 2 would be undefined. I plugged the 2 into my new function right here. So 2 plus 1 is 3 divided by 2. So 3 halves is 1.5. Let's do one more example, and then we'll add it to our note card. So this second one is a little bit easier because I already have it in factored form. What's going to cancel on this one? See how the x minus 2's cancel? Cancel, cancel. All right, so when you cancel, you want to rewrite what you have left. So I have 3x minus 5 over x plus 1. This is my new function. I like circling it so that I can use the note card on the circled function and not get confused. So you're going to go through your steps. Y-intercept, x-intercept, vertical asymptote, horizontal asymptote, and we have a hole because we canceled something. So do you think you can try this set, or do you want to do another one together because it's been a while? Another one together? Are you writing it down? Okay, yep. Did you, yeah, sure. Is he checking you out? Yeah. Fine. I think you had to go out through the main office and, yeah. Okay. Okay. So let's do this one together. Y-intercept. In factored form, I actually have to plug it in and see what I get. What would I get in the numerator if I plug in 0? I'd get 3 times negative 5, right? Negative 15. What about if I plug in 0 here? I just get 1. So negative 15 divided by 1 is negative 15. That's going to be plugging in 0 in for x. Yep. But it's negative 5. So this is, because it's in factored form, it's 3 times negative 5, because 0 minus 5. So that's going to be way off the graph, but I'm just going to plot it down here so that I remember that I do have a y-intercept. My next step, what would make the numerator 0? My x-intercept. What makes, Positive 5 is my x-intercept because x minus 5, positive 5 is what would make that 0. Okay, my next step, my vertical asymptote. What makes the denominator undefined? So I'm only looking at the denominator. So x equals -1. So I have a vertical asymptote at -1. I can kind of see that that's going to be an elbow. Horizontal asymptote. What's the degree of the numerator and the degree of the denominator? They still have a first degree, right? X to the first, x to the first. So I peel off the coefficients in front of those x values. If I distributed, I would have 3x over 1x. So I have to take 3 and divide by 1. So y equals 3 is my horizontal asymptote. So it's going to take some practice. Some of you haven't done any of the homeworks practicing these first 4 skills. So that's why the quiz was a little bit weaker for some of you, or you haven't taken it yet. All right, so here's my first elbow. I know it kind of goes through there. Oh, I should find the hole. So I look back at the original function. What did I cancel out? I canceled out these x minus 2's. So where is my hole going to be? What would have made that undefined would have been positive 2. So it's still at 2. Kind of a coincidence that number 1 and 2 both have a hole at 2. To plug this back in, you're going to go into your circled equation. If you plug in 2, what's 2 minus 5? -3. What's -3 times 3? -9. I'm plugging 2 into the denominator. What's 2 plus 1? 3. So I'm taking -9 and dividing by positive 3. So -3. My hole is at 2, -3. I almost passed through that point. I'm just going to put a little circle on my graph there at 2, -3. I guess I should have found the hole first. All right, did I find the other elbow? No. I can assume it's probably in this top left because there's no other x-intercept, so it probably can't pass through here. But what would be a good value to plug in to figure that out? When x is beyond -1, so maybe like x is -2. All right, so plug -2 into this original function and see what you get. I'm taking -2. I got to figure out where my other elbow is, right? Somewhere over here. So I'm plugging in, this is -1. So I'm going to plug in -2 into the original circled function up here. What would that be? 3 times, this would be -7, right? So that'd be -21 divided by what? -1 on bottom is positive 21. So it's going to shoot way up here beyond my region, but I can tell the elbow must pass through that point. -2, 21. So there's some factoring involved, but steps 1 through 4 have stayed exactly the same, and then the hole is your step 5. So what I always tell students, on your note card, before you write number 1 or somewhere at the top, write look for a hole first. Because if you do all these steps and then you try to cancel, it's going to mess up all these steps. You have to cancel first. So somewhere at the top of your note card, write look for a hole first so that you remember that, you got to factor and cancel first. So then on the back of that, I'd like you to add step 5, how to find a hole. And so we're going to put an example of a function that's in factored form. Let's do the one that we started with, x minus 2, x plus 1 over x times x minus 2. So show that for there to be a hole, you have to have a rational function that is factorable, and then you cancel, right, your x minus 2's. So show that your new function would be that after you cancel. And then I have to explain, how do I find the whole? So the whole is, put an arrow to this factor. What makes this 0? So when x equals 2. Does that help you figure out how to find the whole? So whatever you canceled, what should have made that 0? 2. So that tells me my whole is at 2. I'm going to write whole underneath this. And then we need to write down that what we would do is plug the 2 into this function over here. So maybe write another arrow that says plug in 2 over there. So you'd have what? 2 plus 1 divided by 2 is 3/2. Or you could write out another example and add another example, or write it in a more clearer way. But you cancel, you figure out what made that 0. My whole is at 2. I plugged the 2 into the new function and I got 3/2. So 2 comma 3/2 was the whole. So let's do one more, because I want to show those of you that hate factoring, I want to show you a shortcut. If you know that you're probably looking for a whole, I want to show you how to can I move this, or are you still using it? Okay. Huh? Yep. Everyone added it to their note card. Anyone need a new note card? Because you could just write this on the back of it and then you got to rewrite the front. Because you can still use the note card for Friday's quiz, and we'll use Friday's quiz unless you're in here for flex before then and you just want to take quiz 1 or retake of quiz 1. I'll just use quiz 2 to replace quiz 1 as long as quiz 2 is higher, or if you were absent. You let me know when you're ready to. I'm just going to look at problem number 3. Okay, so if I'm looking for a whole, especially like on homework 2-4, there are probably a lot of whole problems. What factor would have to exist in the denominator for there to be a whole on this problem? It would have to factor into 2x minus 1, right? If they're going to cancel with each other. So here's a way, you probably want to do it, with a pencil if you're on a test, but I know that 2x minus 1 is going to cancel because I wrote this problem. You can just search for what the other factor is if you know that 2x minus 1 is one of the factors. What would have to go here so that 2x times what gives me 2x squared? I know that has to be an x, right? Because 2x times x is 2x squared. What would have to go over here? I'm trying to multiply to get 3. Negative 1 times negative 3 is 3. And then I could just double check that this does give me negative 6x and this gives me negative 1x. So see how I kind of used backwards factoring? I was looking for 2x minus 1 to cancel. So if it doesn't, you know that there's not going to be a whole, and you could factor using, like the box method. Huh? Because that's what your outer plus your inner have to add up to, and see how it does add up to negative 7x? Okay, so I'm going to cancel the numerator with the 2x minus 1 in the denominator. Here's where some students mess up. Your new function is 1 over x minus 3. So anything divided by itself is 1. Don't put a 0 in your numerator. And you need to show that x minus 3 is in the denominator. So now that you have your new function, you're going to answer y-intercept, x-intercept, vertical, horizontal, whole. The same 5 steps every time. If I plug in 0, what do I get? Plug in 0 for x. What's my y-intercept? Negative 1/3. Are you with me? 0, negative 1/3. Step 2, look at your numerator. What is your x-intercept going to be? Can I ever make my numerator 0? No. So if there's no x up in the numerator, there can be no x-intercept. Now I just move down to the denominator. What's my vertical asymptote in the denominator? What will make this undefined at 0? When x is 8 or when x is 5, what does x have to be? 3. So that 3 minus 3 gives me 0. X equals 3. Oh, I guess I could be plotting some of this stuff. A y-intercept at -1/3, so that's like really close to 0. No x-intercept. A vertical asymptote at 3, vertical. Okay. Okay, compare your numerator power to your denominator power and figure out which rule that is. That's 4 on your note card. And am I going to look at A, B, or C? Denominator is bigger, numerator is equal to denominator, or numerator is bigger. So this is just a constant. This is a linear function, so my denominator is bigger. So that is choice 4A on your note card. So y equals 0. That's why there was no x-intercept. So that kind of makes sense. Okay, where is my hole going to be? So what x value would have made this canceled out factor undefined? So I've got 2x minus 1, positive 1/2, right? And if you don't know that in your head, 2x minus 1, you set that equal to 0, you add 1 to the other side, and then you divide by 2. But wouldn't you agree that 2 times 1/2 minus 1 would have given me 0 here? So 1/2. This one you might not know how to do in your head, but I have to plug in a half into this new function up here. So I have to take 1 and divide by 1/2 minus 3. So put it in parentheses in a calculator. I'll show you how to do it in a minute by just using the reciprocal. But what is 1 divided by 1/2 minus 3? And I'll show you how you could do it if you didn't have a calculator. It would be -2.5, wouldn't it, on the denominator, which is -5/2. What happens when you divide by a fraction? Does anyone know? Multiply by the reciprocal. So the answer should be -2/5. Those of you that did it on a calculator, did you get -0.4? Great. So as long as you got either -0.4 or -2/5, you can graph the hole. So the hole is, it's kind of hard to show, but this elbow goes like this, right? So we had our y-intercept here. The hole is slightly lower, so it goes through that and then it goes straight down. And then let's see, if I plug in 4, isn't the answer just 1? Because 4 minus 3 would be 1 in the denominator. So 4, 1 is the other side of my elbows, like this. So if you aren't here tomorrow because you're a junior,